Welcome to the world of statistical data analysis. In today's data-driven society, understanding how to interpret and analyze data is a vital skill. Whether you're a student, a business professional, or simply curious, mastering data analysis can help you make informed decisions and uncover hidden patterns. In this video, we'll guide you through the essentials of statistical data analysis, starting from the basics and gradually moving into more advanced concepts. Let's embark on this journey together and see how numbers can tell powerful stories. Before diving into analysis, let's clarify what statistical data actually is. Statistical data refers to information collected for analysis and interpretation. This data can be numerical, like sales figures, or categorical, like survey responses. The goal is to use this data to identify trends, make predictions, and support decision-making. Understanding the types of data you're working with is the first step in any analysis process. Next, we'll explore the different types of data you might encounter. Data comes in various forms, and recognizing these types is crucial for proper analysis. Broadly, data is classified as quantitative or qualitative. Quantitative data includes numbers and measurements, such as height or income. Qualitative data, on the other hand, describes qualities or categories like colors or brands. Each type requires different analysis techniques. By identifying your data type early, you set the stage for accurate and meaningful results. Foundation of any analysis is reliable data collection. This process involves gathering information from various sources, such as surveys, experiments, or existing records. The accuracy and relevance of your data directly impact your analysis outcomes. It's important to use consistent methods and document your process. With well-collected data, you can confidently move forward to the next steps of analysis. Once you have your data, it's time to clean it. Data cleaning means checking for errors, missing values, or inconsistencies that could skew your results. This step might involve removing duplicates, correcting typos, or filling in gaps. Clean data ensures that your analysis is accurate and trustworthy. Skipping this step can lead to misleading conclusions, so always take the time to prepare your data properly. After cleaning, organizing your data is essential. This often means arranging it into tables or spreadsheets, labeling columns clearly, and ensuring consistency throughout. Well-organized data makes it easier to spot trends and perform calculations. It also helps others understand your work if you need to share your findings. Organization is a simple step that pays off throughout the analysis process. Descriptive statistics are the first tools analysts use to summarize data. These include measures like mean, median, mode, and standard deviation. By calculating these values, you get a quick overview of your data's central tendencies and variability. Descriptive statistics help you understand the general shape and spread of your data before diving into deeper analysis. Visual representations like charts and graphs make data easier to understand. Common tools include bar charts, line graphs, and pie charts. Visualization helps you spot patterns, outliers, and trends that might be hidden in raw numbers. It also makes your findings more accessible to others, especially those who aren't familiar with statistics. Frequency distribution shows how often each value occurs in your data set. This can be displayed as a table or a histogram. Frequency distributions help you see which values are most common and whether your data is skewed. They're a fundamental part of exploratory data analysis and set the stage for more advanced techniques. Central tendency refers to the middle or typical value in a data set. The three main measures are mean, median, and mode. The mean is the average, the median is the middle value, and the mode is the most frequent value. Each measure gives you a different perspective on your data, and choosing the right one depends on your data's characteristics. Dispersion measures how spread out your data is. Common measures include range, variance, and standard deviation. These statistics show whether your data points are clustered closely together or widely scattered. Understanding dispersion helps you assess the reliability and consistency of your data, which is crucial for making sound conclusions. Probability is the study of chance and uncertainty. In data analysis, probability helps you estimate the likelihood of different outcomes. Understanding basic probability concepts like events, outcomes, and probability distributions is essential for interpreting statistical results and making predictions based on your data. Sampling is the process of selecting a subset of data from a larger population. Common methods include random sampling, stratified sampling, and cluster sampling. The goal is to ensure your sample accurately represents the whole population, so your analysis results are valid and reliable. Choosing the right sampling method is a key step in any statistical study. Inferential statistics allow you to make predictions or inferences about a population based on a sample. Techniques include hypothesis testing, confidence intervals, and regression analysis. These methods help you draw conclusions that go beyond your immediate data, making your analysis more powerful and insightful. Hypothesis testing is a core part of inferential statistics. It involves making an assumption about a population parameter and using sample data to test that assumption. The process includes setting up null and alternative hypotheses, choosing a significance level, and interpreting results. Hypothesis testing helps you make objective decisions based on data. Confidence interval gives you a range of values that likely includes the true population parameter. For example, you might estimate that the average height of a population is between 160 and 170 centimeters with 95% confidence. Confidence intervals provide a measure of uncertainty and help you understand the precision of your estimates. Regression analysis is used to examine the relationship between variables. The most common type is linear regression, which models the relationship between a dependent variable and one or more independent variables. Regression helps you make predictions and understand how changes in one variable affect another. It's important to distinguish between correlation and causation. Correlation means two variables move together, but it doesn't necessarily mean one causes the other. Causation implies a direct cause-and-effect relationship. Understanding this difference prevents you from drawing incorrect conclusions from your data. Outliers are data points that differ significantly from others in your set. They can result from errors or represent rare events. Outliers can skew your analysis, so it's important to identify and decide how to handle them. Sometimes, removing outliers is appropriate, while other times they offer valuable insights. The normal distribution, or bell curve, is a common pattern in statistics. Many natural phenomena like heights or test scores follow this distribution. Understanding the properties of the normal distribution helps you interpret data and apply statistical tests appropriately. Skewness measures the asymmetry of your data distribution, while kurtosis describes its tailedness or how outlier-prone it is. These concepts help you understand the shape of your data and whether it deviates from the normal distribution. Recognizing skewness and kurtosis is important for choosing the right analysis methods. The chi-square test is used to examine relationships between categorical variables. It helps you determine whether observed differences are due to chance or a real association. This test is widely used in survey analysis and research studies involving categorical data. T-tests and ANOVA are statistical tests used to compare means between groups. A t-test compares two groups, while ANOVA can handle 3 or more. These tests help you determine if differences between groups are statistically significant, guiding your conclusions and recommendations. Non-parametric tests are used when your data doesn't meet the assumptions required for standard tests like t-tests or ANOVA. Examples include the Mann-Whitney U-test and the Kruskal-Wallis test. These tests are more flexible and can handle data that isn't normally distributed or has outliers. Time series analysis focuses on data collected over time, such as monthly sales or daily temperatures. This type of analysis helps you identify trends, seasonal patterns, and cycles. Time series techniques are widely used in economics, finance, and environmental studies. Forecasting uses historical data to predict future values. Techniques include moving averages, exponential smoothing, and ARIMA models. Accurate forecasting helps businesses plan for the future and make strategic decisions based on data-driven insights. Data mining is the process of discovering patterns and relationships in large data sets. It involves techniques like clustering, classification, and association rule mining. Data mining helps organizations extract valuable insights from their data, leading to better decision-making and innovation. Big data refers to extremely large and complex data sets that traditional analysis tools can't handle. Challenges include data storage, processing speed, and ensuring data quality. Overcoming these challenges requires advanced technologies and new analytical approaches. Machine learning uses algorithms to automatically learn from data and make predictions. In statistical analysis, machine learning can uncover complex patterns and improve forecasting accuracy. Common applications include classification, regression, and clustering tasks. Ethical considerations are crucial in data analysis. Analysts must ensure privacy, avoid bias, and report results honestly. Misusing data can lead to incorrect conclusions and harm individuals or organizations. Following ethical guidelines builds trust and credibility in your analysis. Once your analysis is complete, it's time to report your findings. Clear, concise reports help others understand your results and their implications. Use visuals, summaries, and straightforward language to communicate your insights effectively. Good reporting turns complex data into actionable knowledge. Even experienced analysts can fall into common traps like misinterpreting results, ignoring outliers, or using inappropriate methods. Being aware of these pitfalls helps you avoid mistakes and ensures your analysis is robust and reliable. Always double-check your work and seek feedback when possible. Statistical software like Excel, SPSS, or R makes data analysis faster and more accurate. These tools offer built-in functions for calculations, visualizations, and advanced analysis. Learning to use statistical software is a valuable skill for anyone working with data. Interpreting the output from statistical software is just as important as running the analysis. Focus on key results like p-values, confidence intervals, and effect sizes. Understanding what these numbers mean helps you draw accurate conclusions and communicate your findings effectively. Statistical data analysis is used in countless fields, from healthcare and business to sports and social sciences. For example, companies analyze sales data to improve marketing, while researchers use statistics to test new treatments. Real-world applications show the power and versatility of data analysis. Let's look at a business case. A retail company collects sales data to identify best-selling products and customer preferences. By analyzing this data, they can optimize inventory, tailor promotions, and increase profits. This example highlights how statistical analysis drives business success. In healthcare, statistical analysis is used to evaluate treatment effectiveness, track disease outbreaks, and improve patient care. For instance, hospitals analyze patient data to identify risk factors and develop better treatment plans. Data-driven decisions lead to better health outcomes. Sports teams use data analysis to evaluate player performance, develop strategies, and gain a competitive edge. By analyzing game statistics, coaches can make informed decisions about lineups and tactics. This data-driven approach has revolutionized the world of sports. The field of data analysis is always evolving, with new techniques and tools emerging regularly. Staying up to date through courses, books, and online resources keeps your skills sharp. Embrace lifelong learning to stay ahead in this dynamic field. Data analysis often involves teamwork. Collaborating with others brings diverse perspectives and expertise, leading to more robust results. Sharing data, discussing findings, and peer review are all important parts of the analytical process. Effective communication is key to successful data analysis. Tailor your message to your audience, whether they're experts or newcomers. Use clear visuals, simple language, and real-world examples to make your insights accessible and actionable. The future of data analysis is bright, with advances in artificial intelligence, automation, and big data technologies. These innovations will make analysis faster, more accurate, and more accessible. Staying informed about trends ensures you're ready for what's next. Let's recap what we've covered: the basics of data collection, cleaning, and organization, key statistical concepts like central tendency and dispersion, advanced techniques such as regression and forecasting, and the importance of ethics and communication. Mastering these skills will empower you to analyze data confidently and effectively. Ready to put your knowledge into practice? Start by analyzing a simple data set, applying the techniques we've discussed. As you gain experience, tackle more complex projects and explore new tools. The journey of learning data analysis is ongoing and rewarding. Statistical data analysis opens doors to new insights and opportunities. By developing your analytical skills, you can make better decisions, solve problems, and contribute to your field. Keep exploring, stay curious, and let data guide your way to success.